Hello, welcome to the episode of Being There, Done That. Again, with my glorious co-host Francesco Cesarini.
Hi, I'm Francesco, apparently today glorious co-host, Wondering Tomorrows. Today we're continuing a series about the Erlang virtual machines out there, and it was the perfect excuse to reach out to Maxim Kharchenko. About 10 years ago, under the supervision of Stu Bailey, he was at the time Infoblox CTO and founder. We tried to build the entire network as an Erlang application. So not just a piece of it, just imagine the switch firmware, the controller, and the whole stack. And Maxime built the half which ran without an operating system. The other half was my team at Erlang Solutions, and it was really really good to be back in touch. It's been a while, and it's also seeing this as an excellent opportunity to bring all our listeners up to speed with what we had back then, as it feels that still today the industry is in catch up mode. So before we start talking about what we had, Maxime, why don't you go in and introduce yourself and start with how you pronounce your name, your surname actually.
Yes. Yeah. Yeah. So my name is Maxim Kharchenko. It's like how you pronounce it in Ukrainian. More or less a software developer, but I've been in sales and marketing, and I've been in management and business development and all these different roles. I even taught at the university. But like looking back at my life, I see that the software development is the my core thing, and the probably the biggest achievement in this field. My biggest achievement is this re-implementation of the Erlang virtual machine, which we call the Erlang on Zen. It's pretty unique, is that it's complete, it's performant, and it also runs without operating system, which is it was a remarkable achievement at the time, because it's the whole thing happened like 15 years ago, about around that time. Yeah.
I agree. It's always way ahead of its time. Maxime, before we start getting into Erlang on Zen and the Ling VM, you actually built an Erlang runtime from scratch. Wasn't the fork of the beam, wasn't the modification of existing code base. It was a kind of clear cut implementation. Whilst doing that, what was the moment where you were actually ready to quit, and what kept you going?
Yeah, it was a long like path. So I really spent maybe 5, maybe 8 years like building, re-implementing this virtual machine over and over, until I got to the point that it was more or less as good as being. So and actually I remember this like the very first moment, and I realized so that it is easy to implement a virtual machine. It was like a one-page C code which implemented some very easy stack-based virtual machine, and it actually produced some output. So it just calculated the sum of two numbers or something like that. And at that point, I realized so that virtual machines are relatively easy. But there were other motivations. I was actually, why virtual machines at all? So I was thinking about how to build a system which runs forever. It was all about, for me, it was all about like isolation of the of parts which may fail, and only after a while, I noticed. So that it's already thing which exists. So this is how I discovered Erlang. So it was not like Erlang first, but actually like I came to Erlang from with my own ideas, and they were present in Erlang already. And then also it was then my first look at the Erlang just gave me the feeling that this is the operating system. So this kind of this system has all these components which an operating system has. It has processes, it has all these drivers and whatever. So it just it resembled operating system very much. And what I really don't like is to implement something on top of something, like re-implement the same thing on a new level of abstraction. So
But
what I wanted.
yeah,
Yes.
I'm just curious here because Ling and Erlang on Zen wasn't the only virtual machine you've implemented. It's worth flagging, that you've built
Mhm.
several, but Ling is the only one you open sourced. Why that? Why is that?
Well, yeah, I had the earlier version of the Erlang. The first version even was as it was a process. It was not a unikernel, so it was like a Linux process. But they were like really amateurish, like simple, and it was just more or less like hobby things. So one of them, I remember, it has a complete Erlang compiler written in C, and it was also working. It was the first version which was able to compile itself. So that was that was nice. But they were definitely not professional, and I was never like a big like a community like person for these things. So this is why I don't even think about outsourcing it. I mean, open sourcing it. It was more like a hobby for me.
It sounds
Yeah,
like
but
Joe Armstrong, who's very much of a community person, but in his
yeah.
in his drawer, he had
Mhm.
hundreds of unfinished products, which he'd done 80% of, and just needed the extra 1 or 2 days, to finish off.
Yeah, yeah, yeah. So it was a complete implementation of the. Essentially, it's like I was building an Erlang system, like it was as I mentioned, it was not like only the virtual machine, and also build the compiler, for instance, and it was just trying to get there, like to get so that it can execute like real difficult Erlang code, like standard library, or I don't know, OTP. So can it run OTP? So that was the test. Like the first version was not able to do that. Second version would run out of memory. The next version finally would do something, put the OTP up to the shell. So that was like crazy difficult. And the OLN Zen is the next level. So it's just more or less the same as Beam in terms of approaches. Definitely, Beam is much more polished and versatile.
Before we
Yeah.
actually get
So.
more into Ling, right? I want to get
Mhm.
everybody onto the same page and kind of talk a little bit about what's actually happening underneath. Because when you're developing an application, right, we all know that the Beam runs on some kind of OS, right? There's a lot of stuff in between, but people generally, at least developers who are working with the Beam, generally stop thinking. Usually, I think maybe 90% of the time, maybe more, you stop at the Beam level, and sometimes you go a little bit further down to the OS level. Maybe have some kind of port you need to reach out to, and maybe like use something else outside, like maybe interface with some outside systems. I'd like to talk a little bit more about like the what's actually happening underneath the OS, right? What's a hypervisor, and what specifically is Zen?
Well, it's a hypervisor. So it's what is the meaning of that is that it allows running so-called virtual machine on a single machine. It's I would say it's extremely stripped down piece of an operating system. It gives you very low level primitives like software interrupts, or it manages memory. So this Zen thing is extremely small. It's like hundreds of kilobytes, and it's enough to have this separate virtual machine running on a single server. And then in one of these on these machines, you boot the so-called host operating system, And there is a userland like tools which interface with the hypervisor and lets you, for instance, bring up more virtual machines and so on. So this is different from KVM. So then you kind of launch the operating system, and then you kind of bring up this hypervisor. So this, I just felt that this is more like a cleaner approach. So this is the Zen is the first thing which starts in a computer. Right on top of BIOS, and then it brings up everything else. It just provides this separation of like workloads.
What we did was we got basically you got Erlang running in a hypervisor, but you took a step further because what you did is you took in a software-defined networking switch, which exported OpenFlow, tapped into the hypervisor's networking API. I'd never seen that done before, and I think that was that was Stu Bailey's idea, and it
Yeah,
really worked. Can you tell
yeah,
us a little bit about LinkX
yeah.
and the run on the
This
bare
is
metal?
yeah.
Yeah.
Yeah, this is right. So this is actually the question of why would you run something without an operating system, and why you would do that. So this is just like use an operating system. Everything is fast in this world, and so on. So or it's getting faster, and it will be there eventually. But actually, if you want to, it's just like what kind of latency you can tolerate, or what kind of application you are targeting. For instance, if you can tolerate, for instance, microsecond or millisecond or 100 milliseconds, so that's just you definitely use the operating system and build everything on top of it. But if you want to make latencies as low as possible, for instance, if you are thinking about the part of the networking infrastructure, like in this OpenFlow's switch, so you cannot tolerate like latencies like of 100 microseconds. You want 1 microsecond. So you need to, and if you look at the networking stack of Linux, it's just slow. So it will eat up. I don't know. Even in the best conditions, it will be like 15 microseconds for the packet to pass through the stack. So you just don't. You have to you have to not to use this networking stack of Linux. And if you are running on top of hypervisor, so you essentially can do that. So you can essentially have a networking driver which directly interfaces with a Erlang, which in this virtual machine there is no userland, there is no kernel. Like everything is kernel or everything is userland in this virtual machine. And you essentially you have this networking driver integrated or talking directly into this application code. So you bypassing everything. So this is how we were able to achieve like microsecond level latencies in this OpenFlow switch. Yeah, it's pretty
Sorry, I wanted
remarkable.
to say something because I mean, what you're kind of describing is sounds almost like Docker, but on a how would you say that? More like on a hosting level, like when you have the Kubernetes, right? Because when you turn on an image, I mean, you're basically turning on something in depending upon your application in like milliseconds, right? But in this case, you're actually doing it from like almost on bare metal itself. Is that kind of how we can start to think about it if we want to relate to something more kind of mainstream?
Definitely there is analogy between say like virtualized workloads like what Zen provides and these containers which Docker does. It's the big difference, and the win for Docker is that they have a clear access to persistence. Yeah, they have a clear access to hard disk. So they start with a hard disk. So for them, the hard disk is more or less everything. And then actually, I would like a little digression is that it's actually a flaw in the design of the Unix and Linux in particular. So that and the flaw is that all processes they share file system, so they have the same mounts. So they have access. All processes have access to the same amounts of file systems. So what should be done is to have each process have a separate mounts of separate different operating system accessible to them. So, and then you would get essentially you would get Docker. Linux did it wrong. So for instance, Plan 9 did it right, and Docker fixed that. And what I did with my system is that I completely missed this thing, so that I need persistence, that I need to access hard disk somehow, and it was like a big flaw or big shortcoming of my system. So we were trying to add this access we were trying to invent essentially a new kind of a simplified file system for our system, but it's too hard to do, and so it was
So,
Maxim, made
let me just kind of rephrase what you said. So there's Zen underneath, there's no Linux, nothing between the hypervisor and Erlang, and that's what you built. And it wasn't an experiment. Now, the Beam existed, and the Beam runs Erlang. You could have taken the Beam and stripped it down to run it on Zen. Why didn't you? You know, what did the Beam give you, which did the Beam not give you, which, got you to have to write your own?
This is people were doing this at the time. So people were taking the like language runtimes, and they were trying to build it without an operating system and see what breaks, and they would fix this part which breaks, and eventually you end up with a system which doesn't require operating system. It's actually what I did is it was not like for me it was not the goal was not to have a working to make the Erlang working without operating system as fast as possible. It was as fast as possible in terms of development time. For me, it was like a learning experience. So I can kind of like personally wanted to understand everything about Erlang. I wanted to understand like all the details. I wanted to understand how to build this system, which runs this remarkably fast. So it's just unbelievably fast. Erlang is pretty fast. So and I would and I, actually I was it was really like a journey. It was not definitely not it was not like a commercial project. So then you have a deadline, you have a budget, something like that. Yeah, so for me it was like a exploration. So I guess this is why. So it was not if I would take existing code base and just port it, it is possible. I wouldn't be able to understand everything, and this is what I wanted to understand everything.
I mean, that's a lot of work to do that, right? I mean, how do you even get started in a project like this? Because I mean, the Beam has so many years of effort and so many iterations, right? This is like the third or fourth iteration of a VM for a single language. How do I'm just trying to think about how you would even start to kind of like to decompile everything and to put it all together, because I don't think when you started this we had like a very clear like spec that says like this code gets compiled to this code and then it gets compiled to this byte language on this machine, right? It's a totally different kind of outspec.
Yeah, it was in the beginning. I started with just the Erlang as a language, like a specification for the language, and I just invented a bytecode for that for the first iterations of my virtual machine. I was using absolutely custom bytecode, which was extremely slow actually. And when I was looking at the sources of Beam, and I just trying to understand how people approach all this, how they try to make it faster. And I was like borrowing the ideas, but I was like using only ideas. I was just building the whole thing myself. Yeah, but it was like I don't know, like 5 main years or something. It's like really crazy long project for all these iterations. But the implementation of the last version, it was only took like half a year. So just half a year of like determined work on that, because I felt that I can do it, because I knew how it should look like, and how to make it run without the operating system and all this. And I just like took my time and implemented everything. But but the journey was long, and I just spent a lot of time, like my like personal time, just in the evening. I would work on that. Yeah.
I wanted to ask a question about the design choices, right? We just were discussing about how difficult
Yeah.
it was for you to start to create redesign everything. Can
Yeah.
you tell us about 2 or 3 different design choices that you've made that really, that you're very proud of, right? Because this is such a huge endeavor.
Yeah, a few things are really, really, really good. One of the things is this dynamic instruction code. So there are several levels of instruction codes. I mean, so several levels of intermediate representations, and the last level, which is already like consumed by the virtual machine, it's actually not fixed. So the system figures out the best instruction set for the virtual machine, and uses that for compilation and so on. And it's achieved by compiling and analyzing like a big body of sources, of Erlang sources, specifically like standard library and all these LTP applications. This is what Ling has this mode. Then it can digest all these sources, and then figure out which instruction set will be the fastest for this specific body of sources. Because on a lowest level of the instruction set, they essentially look like macro commands. So they just like a concatenation of several commands with a specific parameters. For instance, you would have some, just an example. So you would have, for instance, an instruction which loads a number into a register. But if the number is, for instance, 3, it happens a lot. So you allocate a new instruction code just for this specialization, essentially specialization of this instruction. And you may figure out in like analyzing this source code, for instance, so that, for instance, loading a number 17 happens a lot. So you allocate a special instruction for loading specifically number 17 into a register. So by doing that, you essentially enable more optimizations by the C compiler, because C compiler has like just sees more constants. It may do all kinds of optimizations and make the code faster. But it comes with the drawback, like the what's stopping you from having a million instructions is that each additional instruction increases the virtual machine, and the bigger code runs slower. So it's definitely, it's just like there was a heuristic which kind of balances out the number of instructions with the potential benefit of making of them running faster. Yeah, so it's so this one of the things which is like design choices a good. I think it's a good design choice.
What about the garbage collector?
Yeah.
Yeah,
Let me.
we had a goal
Yes.
of no garbage collection
Yeah.
process.
Another big thing which I did, it's related to memory management, is that I ensured so that system never it takes care of any potential out of memory condition. So it just there is not a single place in the source code. Then it disregards, like allocates memory and doesn't check and does something like handles the out of memory condition. So the system never fails silently for out of memory. So it was extremely hard, but yeah. So this is a property of the system, which all out of memory conditions are handled properly. So for regarding the garbage collector, the garbage collector is absolutely a central thing in Erlang and in Ling too. I would say it's very important specifically for this for networking applications like this open flow switch.
Exactly.
So
Exactly.
yeah. It's
I was going to
essentially
raise that. Yeah.
for specific applications you want a different garbage collector, and I was optimizing the garbage collector for open flow switch too. So this was this.
In a switch, garbage collection processes are equivalent of packet drops. So yeah, makes perfect sense. And I've got one more item which I think I recall from my list, which we'll also go back to a follow-up question soon. But the whole Zen interface layer. So Ling had to implement a lot of its own drivers for things the OS would normally provide. Can you tell us a little bit about that?
It's not a lot. So all the drivers which I implemented, they are virtual. So like a virtual console driver, virtual networking driver, the virtual hard disk driver. But they are very they resemble the real drivers. So they have interrupts. They have all this ring buffers. So this is exactly what you would find in the real networking driver, or in real disk block device driver. So this is I implemented that, and it is definitely absolutely like 100% different from implementing a virtual machine or an application code. So you have to it's like a kernel development in a way. They're extremely difficult to debug and so on, and then you also stumble upon all these questions about the like memory barriers and what sees what. I still don't really sure why certain things are working there. So I imagine there are people who do understand all these new memory models and for modern processes, but that's not me. And nowadays I work with microcontrollers. They are much simpler.
We'll get back to microcontrollers soon. Yeah.
No, I'm really quite interested and curious about. A lot of work has been put into this, right? You've done a lot of crazy things. I tried doing some research recently, and people were asking, what's the status? I took a look at the GitHub repo. I think it said 12 years ago. Maybe my memory is wrong,
Yeah.
but I
Yeah.
mean, it's crazy that I haven't found any people always doubt things, right? But I haven't found anything negative about this project. It just abruptly stopped. I mean, obviously something didn't work, right? Can you just like in simple terms just explain to audience that like why did the work stop on this? What happened that just didn't seem to be the right fit, at least for right now?
Yeah, it was. I would say it was not a commercial project from the start. So if you would do a commercial project, you would not never do that. Yeah, so it was very extremely interesting and extremely like satisfying project for me personally, for a few people around me, just like proving ourselves and checking things that they possible at all. So for instance, the projects I did like a couple of years ago, it was also similar. So in terms of I borrowed some ideas from that implementation. But as a product, yeah. So it didn't pick up. But we were close. So the guys who were doing the unikernel project for a camel, they were bought by Docker. Those guys, they also were using crazy obscure language, a camel, and they also built a networking stack of their own. So in a way, they were similar, but they continued their work, and we kind of stopped. But definitely it was a big accomplishment for me, and it has a big difference in my life, but not in the market, I guess.
The Ling VM, didn't exist in isolation. So it was, it was the engine inside the software-defined switch, which we call LinkX. And it was the flow forwarding stack switch, and we're going to get into these definitions. ESL Erlang Solutions, where I worked at the time, was building the link switch on the Beam and Linux side. Maxim, so for the listener who doesn't know what software defined networking is and what OpenFlow is, could you maybe just explain what we're actually trying to build and why it required Erlang running without an OS?
Yeah,
Because
so
it was way ahead of its time, and it's where the market's heading today. What we had 10 years ago, I still haven't seen in the market, but it is slowly getting there.
yeah, so there was this big idea. So I guess it's still exists today. So that the conventional computers are fast, and they can actually do the networking processing in the user land, or just not in hardware but in software, like do all the networking processing in software. This is the idea behind networking, behind OpenFlow standard. Well, it's there was. I'm not sure about how it progressed, but at that time there was a few software switches which were doing just that. So they did. So you essentially receive packets, and then you inspect them, and then you apply rules. For instance, you should like forward this packet to some other port, or for instance, you may generate additional packet somewhere else, or you may, increment the count or something like that. and this all happens in a software. And if it's in a software, so you can easily it is easily reconfigurable. It's observable, it's debuggable, all these nice things. So the difficult part is to make it run fast. There are implementations of this idea in C, but we thought, I mean, I guess it's the idea of Stu Bailey, so that it's also possible to do this in a higher level language, specifically in Erlang, and it just be as fast as a C product.
I mean, I remember it had to be fast enough. It had to be fast enough as long as you could, and I think as long as you could stream Netflix, it was fast enough. We didn't need more because, I mean, try to imagine a programming model where you have hundreds of thousands of Erlang nodes. So instead of a process, imagine it being a node, and these nodes, come and go dynamically, executing with location transparency. And as needed, the switch would set up and tear down network connectivity between nodes which were actually communicating with each other. And you were talking about analyzing the layer 2 traffic and optimizing. And what we did is we optimized for latency or for throughput. And what really excited me at the time, and we've had a few episodes about it now, is that the whole security angle is taken away from the hands of the programmer, and it's completely automated because setting up and tearing down of the connections are all done by what was back then a much more sophisticated version of Kubernetes, I would almost argue. And back in 2015, I think the big hype of the moment, which you and I were working on, was big data, and the realization that every year we were actually storing more data that year than all of the previous years put together. I mean, it was exponential, and moving this data was becoming very, very expensive. Ethernet wasn't powerful enough, and here I'm actually quoting Stu Bailey. So instead of moving the data, we would move, to analyze it, we would move the compute to the data. I don't know, am I over romanticizing it, Maxim, or is that how you saw it as well?
So essentially, if you have this more like moldable this software product, so then definitely you can have have a better orchestration of like a multiple switches and so on. Yeah. So and what essentially what we did, like our contribution to this open flow switch, is that to make it really like to bring the latency down. So what I did is just analyze the fast path, which like where the packet is moving through the switch, and it just like makes sure so that it's never linger for a long time anywhere. So that's what we did. Regarding like bringing compute to the data, I guess it's not always possible. So if it's just a networking component, well, you have like stream of events or something coming your way, and you have to apply these rules, do something on a for instance, like a conversion of a protocols or something, and you are not. It's not possible to move these decisions to the data, to the origin of these packets. What I would think where the thing is heading, and I actually started to explore this a little, is that it is possible to do a lot of processing similar to what OpenFlow switch is doing inside the networking cards. So that's what I'm interested in. So there are this new, it's not exactly new, but newer networking cards which have an FPGA on them. So this is where you can really process this packets fast and do essentially the same thing what OpenFlow switch is doing, but in this essentially in like a generated hardware, in an FPGA. So this is what I actually want to look into when I have more time on my hands.
You did mention Stu Bailey. Now, Stu Bailey at Infoblox gave the at EUC 2014 keynote, and around his work, and he quoted John Gage's 1984 line, "The network is the computer," and argued that what you were building and was actually how you finally made that true. Was that actually also how you thought about at the time?
Yeah, so we kind of have a lot of alignment between me and Stu in terms of approach to networking and computing. I would mention just one aspect of all this. What draws me into software, and I'm coming into software mostly from a mathematical perspective. So I want to think which are like run predictably, and you can essentially to say something about the system with confidence. So, for instance, you are sure so that this function will produce this result, and that it always will be the same, and it's like a mathematical truth. Distributed systems, they are not like that. So they are like they have this like inherent they're inherently indeterminate. So they just we are try to make them work, and sometimes they do, but we're never sure about the properties of the system. And it's kind of boils down to the so that potentially it's even not possible to build like a mathematically like robust model of the distributed systems. You will always have to hope and try and measure a real system and make experiments. This is what's this line of thinking, which was like we were discussing with Stu at the time, and yeah, we were thinking about if the like right model for distributed computing. Maybe OpenFlow is there some kind of right approach, or maybe this short-lived instances is the right approach.
That was the bet. I mean, what you're trying to describe in this whole vision. Ling was the engine, LinkX was the switch, Loom was the controller, and we aim for a whole network as an Erlang application. The flow forwarding bet didn't fully land. The software-defined networking wave crested, and OpenFlow never really became the standard. Xen gave way to KVM, so kernel-based a kernel-based virtual machine. The industry moved in a different direction. So, in one sentence, what happened?
Well, it's just the market has its say. So they are. So it's not about most of the time. It's not about technology. It's usually about other things. It's just about like availability of talent, or if the right person knows or prefers like personally something else. And
I mean,
yeah, so it's a market. They typically do not. It doesn't choose like the best things available. It just
the VHS,
choose.
the VHS versus
Yeah.
Betamax argument.
Yes.
Yeah.
Yeah.
I mean, it's I mean, the provocative question I have, and we now know the answer. The industry didn't stand still. It went on to
Mhm.
Docker and Kubernetes
Yeah.
and Kafka, and most developers would say that's progress.
Mhm.
In my keynotes at ElixirConf in Latin America in 2019 and the Reactive Summit in 2020, I actually argued that it was a step backwards. So we'd taken two steps forwards and one step back because what we had was way ahead of its time. Do you agree?
Potentially. I definitely would like to think that I was ahead of the time. Maybe not. So definitely, what I don't like in a development, in recent developments, is that people piling stuff upon stuff. So it's in a Kubernetes. So you essentially you have a like a level of an operating system, and then you have yet another level of like Kubernetes, and then you inside the Kubernetes you essentially re-implement the same primitives as you have inside the processor. So it's just like the same mechanisms with some additional features, but implemented in new levels. So it looks like a natural evolution, but we are not
Uh,
all natural. So like let's do some intelligent design. So sometimes you need to step back and do everything from scratch. So because it will be much better. But it looks like the market forces they just do not provide time for that. So it's just like they reward like piling layers upon layers in the current systems. So current systems are pretty awful in terms of like how wasteful they are from bottom up. So starting with the processor, starting with going on to the operating system, the applications on all these language runtimes, they just like extremely wasteful. And they could be implemented like 100 or 1,000 times like smaller. So this is what I would want to see, but probably I won't.
Uh,
Especially with a
Sorry, I just
new
wanted to step in
new.
and say, like about the whole Betamax and VHS thing. I
Mhm.
remember talking to my dad about this. I mean, like, I talked to some younger people my own age about DVDs nowadays versus
Mhm.
downloading, which is kind of crazy. I feel like one of those old farts now. But sorry, coming back to the main question, right? We're Francesco mentioned that basically it's kind of like a step backwards. I mean, at the same time, Kubernetes and these kind of style of things is basically running like the world in terms of infrastructure. Is it even safe to say like whatever is actually kind of working and running is the right thing? Like with Betamax, I mean, it was a clearer picture from what I can understand, but you had much less tape. I mean, does that mean it's actually the right way to go about it in terms of we can record more things that's actually better than having better quality? Or do you have any thoughts on this kind of argument?
Yes, it's the then like people like they vote with their money, and they kind of choose what's the best for them. And but I just don't think that this is the whole story. So there is also a question of what's right from the perspective of being simple, or of being strict, or being like probably correct. And these are not directly rewarded by market forces, and this is why people do not put sufficient resources into like this kind of properties of the systems. But me, just personally, this is what I value. I want a system to be as small as possible. I want to be like provably correct. I want to be like as fast as possible. and so on. So it's definitely not what's like billions of people on Earth are looking for. So people want things which work, and they can watch Netflix and stuff.
Now I'd actually like to ask another question, right? Another kind of contender that's basically come out of nowhere is WebAssembly, right? I mean, WebAssembly in some contexts is almost kind of used like your kind of Erlang on Zen or Ling, where you can just kind of zero boot time. You can just start up into it. It's kind of this weird. I'm not even sure what to even call it. This weird, like I said, contender that came out of nowhere. How do you feel about this coming out and all of its kind of benefits in terms of single purpose, sandboxed? You have to actually opt in to use certain features. It's very minimal. Is that the idea coming back around through a different door, actually proving that what you, Francesco, and Stu were actually basically right about?
In a way, I guess it's just the whole computing infrastructure as a whole it looks like that. So you would first have some shared layers which like for instance all the applications need, and then you would have some little and purpose built applications for a specific task. But then some applications they would become huge, and they become like a platforms of their own. So what I wanted is to eliminate a few of these layers, or at least to demonstrate, so that it is possible to remove these layers and to make this features which are doing useful things, and they would not require all this additional layers, because these layers, they're complex, they're slow, and also just people do not like almost stop like just they stopped to understand the complexity behind what they are building on top of. So very few people, I would say, understand like intricate details of the operating system. Even fewer understand how the modern processor works. And I would say it's just this complexity is not justified. It should be simpler. It should be taught in schools, and should be understood.
Mm.
And more people should be able to build a new processor, a new operating system. People should be able to build computing systems like from scratch, from a
Right.
piece of silicon.
Yeah, no, absolutely, Maxime. I completely, second that, and I completely agree with you. It should be taught everywhere, and it should. Simplicity is beauty. So yes. Now, Ling, so wrapping up now. Ling has been on GitHub since 2014. It's not been actively maintained. I think the last commit was something like 11 years ago. For a developer listening who wants to run Erlang on Zen today, what's the honest state of the code base? What works? What doesn't? And how much work do you think it would take, to get something running?
The only problem is that Erlang, the big Erlang, and it doesn't it keeps progressing. So the Ling uses the same standard library as the Erlang version like 17 or something. So now we have the Erlang like 29. Yeah, so it's definitely behind in this. But if you take the standard library from Erlang version 17, so it will work. So it's not a big deal in this regard. Yeah, so it's possible to bring it up to speed, to fix potential issues with using the new standard library. I just don't think it's worth it. So it's definitely possible. Yeah, but I would think that it will be just maybe like a student project to check your skills. something like that, definitely. Or if somebody decides to do something along these lines, and actually hard to say. So it should work, but not with a new Erlang sources.
I would like to just to talk a little bit more about that, right? What exactly do you think should be the first step in terms of when people want to actually bring this project back to life? Because like I said, there's a lot of people online talking about it. They're interested to actually use it, but it's been, kind of aloof for what's going on. What would be like the very basics you think they need to do first? I'm guessing probably not add in native records, right? The new feature that just came out recently. Maybe that's a little bit too much and not really useful at the moment.
Yeah, so just you have to have Zen on your system, and that's it. You just you need, maybe you will have to have an earlier version of C compiler, something like that. But then you just run make, and it produces you an image, which is like Zen image, and then you just start your virtual machine using Zen tools, and that's it. It should just work.
Coming back, right? I feel like your project is quite unique, and maybe it could be an inspiration, or maybe it was one of the inspirations on Atom VM in terms of bringing Erlang to a whole new place, right? If you look at like Nerves and a lot of these other projects, we're still carrying the OS around. But with Atom VM, I'm not exactly sure how it works though. But at least it's bringing it to a whole new architecture in terms of microcontrollers. I mean, how do you feel about this kind of direction that the Beam can actually go into?
Well, it just you you may use the project as just a demonstration, so that that the OS is not strictly necessary. So you should then you start thinking about your software system. You should not start with a. Of course, we have Linux, or for instance, of course we have Node.js. You may start thinking about, we just have an x86 microprocessor, and start from that. Or you may think, I only have this I don't know how you call it, like these elements of the FPGA. So this is what I got, and I built a system from that. And actually, there's networking applications, and like these fast things, they definitely benefit from cutting off these layers in the software, or even in the hardware. And also the current microprocessors, they are as powerful as the big servers they used to be in like 12 or 15 years ago. So definitely you can run Erlang, you can run Linux on it, or you can run Zen on these microprocessors. I haven't tried, but it is definitely possible. And what's it's actually this the question about how to make systems very reliable. It's like highly available. This is what like the promise of Erlang. Yeah. So even today, I constantly stumble upon these problems. Then the high availability is what is needed, and it is possible to implement it using just in the hardware. So you would have multiple hardware nodes which are failing, but system still operates. But it's also possible to implement these things in software using Erlang or similar approach. Yeah, so this is these questions are still on the agenda, and things like unikernels and Erlang and Zen could be like building blocks for better systems in the future.
where can we go to kind of keep up on what you're currently working on when you are working on this kind of stuff? Because you are busy with other things at the moment, right? I mean,
Actually, as I mentioned, so that I was implementing a system a couple of years ago. I was borrowing ideas from this project too. So it was what I was building. It was essentially a fixed gateway. So it's just a thing which processes financial information, and it also applies rules to essentially to packets, which are messages, and also it has all these tables, and it also has a virtual machine inside it, which executes these rules. So in a way, it was some parts of this system was inspired by Erlang and Ling in particular. But it was written in C, and I was using this newer subsystem in Linux, which more or less kind of it's an attempt to fix the problem of constant switching between kernel and user mode in the system, which is essentially what slows the whole thing down. Some ideas of these projects, they still being applied and still live on.
So thank you so much, Maxime, for being on the show. Just to recapitulate, I mean, to summarize, what we said, in this episode, we discussed, the network as an Erlang application, and Erlang without an operating system. It was a bet on a programming model which, was taken 15 years ago, and which, the industry wasn't ready for, and that's, Erlang on Zen and the Ling VM. And yeah, and it's something, you've gone in and actually built yourself. But
Yes.
as you were just describing now, the problems Ling was solving back then have not gone away. They've just come back and they're called something different, but they're still very, very much the same. So, yep, if you're new to the show, this is what the Beam There Done That podcast does. It's about the people who make the bets that shape the ecosystem. Some bets you win, others you lose. And, what we make sure is that we are actually able to step in and learn from both. So, hit subscribe, as we've got multiple episodes coming on other Erlang virtual machines, all in the making, past virtual machines and current ones as well. So yeah, Maxime, thank you so much. We're hoping for better times and peace, as, I'd love to reconnect in person. It has been a while. Until then, please stay safe. And just for the record, this episode was recorded June 3rd, 2026.